welcome to the 8th Annual ARPA-E Energy Innovation Summit. I am ecstatic you've joined us as we view the technology shaping America's energy future and explore the road ahead. We've developed an exciting program for you. Here on the main stage, you'll hear from leading experts and policymakers as they share their vision and insights on energy innovation. These will include world-renowned economist Jeffrey Sachs, the CEO of Duke Energy, Lynn Good, and Senators Lamar Alexander and Cory Gardner. As in the past years, ARPA-E's program directors and fellows will be sharing their visions for new technology concepts during the fast-pitch breakout sessions. I encourage you to listen, learn, and challenge their ideas. Each year, the unquestionable highlight of the summit is our technology showcase, which opens at 4:30 this afternoon. Nearly 250 ARPA-E projects will be exhibiting, including more than 100 new ARPA-E project teams that are showcasing for the first time. We have an incredible range of technologies on exhibit, everything from methane sensing drones to mitigate natural gas leaks to new flow batteries that can store energy on the grid. These ARPA-E awardees represent America's best and brightest energy innovators. Most of all, I encourage you to spend your time meeting new people, sharing your ideas, and engaging with our staff. Please come see us at the ARPA-E booth in the middle of the showcase floor. ARPA-E has continued to host the summit each year because we understand that in order to advance energy technologies, in order to make an impact, it really requires the action and commitment of many, from technologists and government agencies to policymakers, the private sector, and the press, who help us inform our fellow Americans on how their tax dollars are being put to use for the benefit of all. At ARPA-E, we pride ourselves in being this convener in uniting diverse communities to solve our nation's biggest and most pressing energy challenges. All of us know the challenges we face. We need to provide secure and reliable energy for all Americans, and we have to satisfy increasing global demand for energy while conserving our natural resources and protecting our environment. We've made some impressive advancements, many of which you'll see on the showcase floor, but we've yet to reach our full potential to be the world leader in energy technology. If we don't up our game as a nation, we risk falling behind. With the collective brainpower and resources of our nation's research infrastructure, combined with our entrepreneurial spirit and the relationships in this room, I believe we can and we will overcome each of the challenges we face. A decade ago, Congress charged ARPA-E with supporting high-risk R&D in order to maintain U.S. leadership in energy technologies and to accelerate the commercial adoption of those technologies. Congress tasked ARPA-E to focus on technologies that would reduce energy imports, improve energy efficiency, and decrease emissions. In those first few years, the enormity of that task could have discouraged anyone. But ARPA-E was able to tap into an extraordinary resource, all of you. It's no secret that energy technologies face incredible obstacles to commercialization. For any new technology to compete, it must not only be cheaper, cleaner, and better, it must also support our expanding need for energy to power modern life. Even if technologies can compete, getting to market is fraught with risk. Energy technologies need investors to support their ideas. They need time and a robust infrastructure to develop and scale up concepts. But most of all, they need a passionate, dedicated, and talented energy innovation community. And that is exactly what ARPA-E, in partnership with all of you, is continuing to build, an energy innovation community. And so here we are today, just 8 short years after the formation of ARPA-E, to celebrate our joint successes. This morning, ARPA-E released new data showing just how well our community is working. Since 2009, ARPA-E has provided $1.5 billion in funding for our projects. To date, the private sector has invested over $1.8 billion into 74 of these projects to continue their development after ARPA-E funding and bring these technologies to market. Let me repeat that. $1.5 billion in ARPA-E funding and $1.8 billion in follow-on investment from the private sector. But it's not just funding that defines success. 56 of our project teams have formed new companies, and 68 teams have partnered with other government agencies for further development. And more ARPA-E funded technologies are now available in the market. These are important indicators that our energy innovation community is really working. Congratulations to the project teams, new companies, and investors. Let's have a bit of fun and celebrate their success over the next 3 days. I want to spend some time highlighting a part of our community that is particularly important: the women and men of ARPA-E. Now, this may sound a bit self-serving, but in my 4 years at ARPA-E, I have had the distinct pleasure to work with the most dedicated and passionate group of people in my career. So please humor me while I give them some of the recognition they so richly deserve. From the start of the agency, we learned very quickly that not only do we not have all the answers, we don't even know all the right questions. During these early years, ARPA-E knew it had to approach America's challenge differently. We needed new ways of exploring the white space. We knew that in order to be effective, we had to be nimble and adaptive. We had to ignore the inclination to roadmap, which for a government agency is quite revolutionary. ARPA-E provides its staff with a degree of freedom that allows us to test new approaches, fail fast, and adapt new solutions that will matter. Moreover, by broadly defining energy technology as any technology that can benefit our energy mission, we're able to explore areas that have been overlooked. From plant biology to plasma physics and everything in between. If it impacts U.S. energy, we will try it. ARPA-E has attracted top talent from some of the leading institutions in energy, from GE and ExxonMobil to Caltech and MIT. People often ask me what attracts these incredible people to ARPA-E. Let me assure you, it is not for the money. It's all about the impact. Our staff are willing to make sacrifices because they know their work can move the needle and improve America's energy future, and we give them the freedom to do just that. We hire the best people, and then we get the heck out of their way. One of our program directors said that when he resigned from his last company, the CEO asked him if he was leaving because they hadn't given him a big enough sandbox to play in. He told the CEO, "ARPA-E offered me a whole beach." My colleagues are some of the most talented, driven individuals I know. I value their tenacity, their creativity, and their quirkiness. And believe me, we fully embrace quirkiness at ARPA-E. But most of all, I value their willingness to be challenged, to be flexible in their approach and open to new ideas. It's what allows us to continue to challenge the research community to solve the toughest and most important energy technology problems facing our country. We will always continue to explore completely new ways of tackling our energy challenges, but we also apply learnings from previous programs to new ventures to build a continuity of effort in key technology areas. Let me give you 2 examples: power electronics and electrochemical energy conversion. Power electronics convert one form of electrical power to another. Today, about 30% of our electricity flows through power electronics, but by 2030, this may increase to 80%. So even modest efficiency improvements mean big energy savings for the U.S. Recognizing this opportunity, we created the ADEPT program in 2010 to enable more efficient power conversion by advancing the basic building blocks: transistors, inductors, transformers, and capacitors. One of our ADEPT performers, Arkansas Power Electronics International, or APEI, developed a silicon carbide-based electric vehicle battery charger that is 10 times smaller and lighter, more efficient, and faster than existing silicon-based chargers. APEI has since been acquired by Cree's Wolfspeed, which is now selling the ARPA-E-funded module in the marketplace to defense and power generation customers. ADEPT was an important program because it identified the need to focus on power semiconductor devices. Silicon-based semiconductors are used in most power conversion today, but we found that wide bandgap semiconductors, such as silicon carbide and gallium nitride, could radically boost the efficiency and performance of power generation. The learning from ADEPT was applied to the creation of the Switches program in 2013. Switches focuses on performance and cost of high current, high voltage devices. We challenge Switches teams to create wide bandgap devices that are cost competitive with silicon by innovating new fabrication methods and new architectures. One of our Switches performers, Monolith Semiconductor, has designed silicon carbide devices that can be fabricated in existing high-volume silicon semiconductor fabs. Using existing silicon fabs creates the potential for producing silicon carbide devices at an enormous cost reduction. Look for the Monolith team in a featured video later in our programming. Just as ADEPT provided direction for creating switches, the Switches program identified the need to develop completely new circuit topologies to fully realize the amazing potential of these new devices. This led to the creation of our newest program, logically enough called Circuits. Through the Circuits program, we intend to develop an entirely new class of efficient, lightweight, and reliable power converters that will take full advantage of the enormous potential of wide bandgap devices. Unfortunately, technology doesn't usually advance in a simple, straight line. As much as we want to build directly and rapidly from components to full systems, we sometimes need to step back and tackle critical challenges at the component level that limit further progress. One such bump in the road came up in switches, and it was the challenge of selectively doping areas of gallium nitride. So we've recently supplemented switches with the PN diodes program to tackle this key problem. You may have noticed by now that we take enormous pride in thinking up very, very clever acronyms for our programs. You might even say we are adept at it. I was hoping for groans. You know, a bad pun, you got to get groans. You may have, oh, sorry, I did that already. Another joke coming, I'll tell you when. The faster ARPA-E can identify problems and convene a community to develop solutions, the greater our impact will be. Our systematic work in power electronics, building from one program to the next over the course of 7 years, proves that. Let me give you another example of a critical component need, this time in electrochemistry. ARPA-E has run multiple battery and fuel cell programs over the last 8 years, focused on reducing costs and improving performance for energy storage applications for both vehicles in the grid and for distributed generation. In our GRIDS program, ARPA-E funded the United Technologies Research Center, UTRC, to design a high power density stack for flow batteries that could deliver more power with a smaller footprint and thus reduce the system's cost. Like all batteries, this flow battery has negative and positive electrodes that are separated with an electrolyte to allow the movement of ions for the charge and discharge of stored energy. For the flow batteries also contain flow fields to distribute the liquid reactants. For the UTRC team, the innovation came in the integration of these components in a compact stack, and along the way, they picked up some new insights on the electrolyte. UTRC partnered with 3M to adapt membrane electrolyte materials used in fuel cells to work in the flow battery system with high currents and without sacrificing efficiency. Bringing advanced membranes together with their unique flow field designs improved the cell power density by a factor of 5. UTRC has licensed its innovations to Vionics Energy, which has attracted significant follow-on private investment and is now selling flow batteries to customers, including the U.S. Army. The UTRC project illustrates how drawing on insights and expertise across communities can yield big improvements for electrochemical systems. In this case, a key insight was on the role of the solid-state, ionically conductive polymer electrolyte membrane. This is an important theme we've seen again and again across our portfolio of battery and fuel cell technologies. Solid-state ion conductors offer enormous potential in conventional batteries as well, including the ubiquitous lithium-ion battery. These batteries currently use flammable liquid electrolytes with a porous separator. However, solid electrolytes offer the possibility to eliminate the dangerous liquids and improve structural stability, meaning much safer and more energy-dense batteries. Recognizing the critical enabling role that solid ion conductors hold for batteries, redox flow batteries, and fuel cells, we've recently launched the Ionics program. Ionics challenges the R&D community to build the separator component from solid-state ion conductors. success could mean a real transformation in electrochemical energy conversion. It's probably no surprise that UTRC has returned as an ionics performer, this time with a new team and a goal of completely reinventing the electrolyte membrane as well as the reactants. By co-developing a new membrane with new reactants, they're seeking to put flow batteries on a dramatically lower cost trajectory and to realize their enormous potential for long-duration grid-scale storage. It's really important that ARPA-E has taken a systematic approach over multiple generations of program directors in key technology areas. But we also look to the broader community to come to us with new concepts. We're pretty smart, but we know there are ideas out there we've never even imagined. That's why we reach out to all of you through our open solicitations. The open program is your chance to challenge us with revolutionary technology ideas. We've received thousands of proposals in our open calls, including completely unconventional approaches that, if proven, would radically transform the way our nation generates, uses, and stores energy. Let me give you just two examples of some of the amazing open projects that are advancing exciting new technologies. First is a project out of UC Berkeley that quite literally visualizes building efficiency differently. Heating and cooling American homes and businesses uses about 13% of our energy, and a lot of that is wasted due to inefficient building design and operation. One of the biggest impediments to retrofitting buildings to improve energy efficiency is simply knowing where the energy is lost. Conventional energy audits are done manually, often rely on incomplete building plans, take days to weeks to complete, and cost thousands of dollars. The UC Berkeley innovator saw a way to pair advanced data analysis with optical ranging and infrared imaging to map the energy losses in the interior of a building. Her team packaged the system into a backpack that allows an auditor to walk through a building, collecting the data that is then rapidly converted into a three-dimensional energy map. They can audit a building in a matter of hours, not days. The project lead spun out a startup called Indoor Reality that is now providing building scans to customers. And she's expanding on these innovations through other ARPA-E projects that are examining new sensing platforms for biofuel crops and smartphone-based scanners for even faster building audits. Brown University is another great example of a team coming to ARPA-E through an open solicitation and challenging us with an entirely new technology concept, this time a novel approach to tidal energy. ARPA-E had not explored tidal power, but we were very impressed at how Brown's proposed hydrokinetic system could maximize power generation while minimizing environmental impact. While most tidal power uses a rotating turbine, the Brown team designed an oscillating hydrofoil controlled with active feedback. The team demonstrated that this novel design could generate up to 2 times more power than standard rotary turbines. Additional tests proved that the system is easier for aquatic life to avoid than a rotary system. In short, their system generates electricity from tides without turning Nemo and Dory into fish chum. I invite you to go witness this technology in action. The team and its commercial partner, Blue Source Energy, have brought with them a prototype that will simulate the device. They'll be demonstrating it tomorrow evening at 6 p.m. on the showcase floor at booth number 750. Let me assure you that no fish will be harmed in this demonstration. ARPA-E is planning another open solicitation in 2018. Now is the time for all of you to start imagining novel ideas and building strong, multidisciplinary teams that could lead to our next amazing open projects. We can't wait to see what you'll dream up for us next year. ARPA-E is very proud of the accomplishments we've achieved in partnership with all of you over the last 8 years. Together, we have built a true energy innovation community. I thank you all for your exceptional service to the nation. But we also recognize that many challenges and uncertainties lay ahead of us. As the great American philosopher Yogi Berra once said, predictions are hard, especially about the future. But let me conclude by boldly ignoring Yogi's sage advice to make this prediction. By working together and leveraging the enormous collective talent of the United States, our new energy innovation community will continue to provide technology options for a better, safer, and cleaner American energy future. Thank you very much.